All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue. Actually, no, back up. Today we are going to be going back to the basics. I mean, technically, yeah, continuing from what we were doing yesterday, but yeah, we're going to be going back to the basics of Git because I realized that I have not been using Git nearly as much as I wanted to in my projects and I should be using it. And as part of that, the Git workflow, something else that I wanted to do was um, also use remotes. So these are essentially remote locations where what you would consider the central repo, where the central repo resides. That's the concept of remote. So you set up a remote and you have the repo present there. You can then clone the repo from there. So you can, after cloning, pull, you can pull new data from there, and you can also push data to there. Um, there's also some slightly more, advanced use cases of remotes, but this is what I'm planning on using remotes for. And I have two use cases for remotes. One is for setting up a local central repo, and another is for setting up a central repo on GitHub. So I'll have to see how I want to go about doing this thing, how I want to go about setting this up, because I do want to maintain two copies. The thing is, okay, so I want to have like a working copy where I actually do my work, and then I want to have what I would consider a central copy of this, a central repo of this, let's say whatever XYZ project. Um, I would have a central repo for this project, either somewhere on the same machine or on another machine across the network. I haven't decided yet how I want to go about doing that, but I do want to have the concept of like a central repo. So I'm in a way self-hosting a lot of my repos that way. Additionally, I wanted to also host some of the repos on GitHub in case if, uh, for whatever reason, I mean, the reason would be that I want to make the thing public and I want to share it with the community. But there are also, I've also had situations where I wanted to just post it on GitHub so that I have my own um, so that I have like a central repo. I have a central copy of it online somewhere, hosted online somewhere, and I can then clone it whenever I want. But then I also made the thing public because I don't mind making it public. Like that specific repo wasn't, um, it didn't have, very sensitive information in it. So I was okay with making the repo public. I've kind of forgotten where I was going with this. Anyways, the point is, let's say I have a Rust project. Okay, I'm currently working on the Rust project. I have a Git repo set up for this project. What I want to do is I want to set up a remote for it, either on the same machine or on another machine. And the way to do that is basically you create what's called a bare repository, a bare bones repository. This is a repo that just holds the the all of the data. It's not something that you can actually work with. You can use it to give me a sec. You can use it to make clones, and you can also like push information on there, but you generally don't work directly on this. Give me a second. Holy shit, dude, what's going on? Is Yo, give me a second. Let me just wipe my pop filter. I think there might be dust on it, so let me just clean it. Okay, I have no idea how that just sounded on stream, but yeah, okay. So, um, what was I saying? So let's say I have a Rust project, okay, and I've set up by default, anyways, Cargo sets up a repo for you in your project in case you want to start using version control. So you already have a repo there. What I want to do is I want to set up a remote where I would host what I would consider the central copy of this repo. And then what I have is just going to be a working copy, and it's going to be essentially a clone of that repo. I don't know what the entire, or I don't remember, I should say, because we have done this before, but I've kind of forgotten it. Um, I don't remember what the workflow is like, how we are meant to how we are meant to proceed with this in terms of like, okay, we have the initial repo, we then create the bare bones repo, which we are going to consider our central repo. We then, I'm assuming, push the main branch over to that repo, because I believe with pulling and pushing, you're generally pulling or pushing branches. Um, and so in my case, it would be just the main branch. So I uh, yeah, so we push the main branch from our working copy onto the repo, and then now that becomes our central repo. Um, Officially, quote unquote, I don't know if there is really meant to be a difference between what's considered the central repo and what's considered a working copy or just a clone. I don't know if there's meant to be like a massive difference other than the fact that, with this central repo, with the bare bones repo, it's literally just the repo. You can't really work with it, at least according to what Gemini has said. And I think even according to the Git docs, you don't really work with that repo. You're not you're not usually using that. You're not usually making commits to it. I guess that's the best way to put it. You are mostly like pushing changes to it and pulling changes from it. But I guess that's where our re-exploration of Git is gonna help us, because that's gonna answer a lot of the questions that I've had. So yesterday we were I think we are past what do you call it? Um, I think we are past the diagrams thing, so I don't need to be in light mode anymore. We were done with this is the index. Okay. Isn't this the index? No, no, this is not the index. This is uh this is one of the pages. Okay, so right. So we have this. We can just go page by page. So we'll go next. So by the way, yesterday we read up on I think it was under what is Git. Yeah, it was under this. And oh, yeah, yeah, this reminds me. Wait, did we finish reading? I don't think we finished reading this. Oh, yeah, yeah, we need to read this. We didn't finish reading this. Let me also open up the conversation that I was having with Gemini about Git. There were two conversations that I had opened up. Okay, it's totally normal to be tripped up by this. Most version control systems before Git, like SVN, actually store deltas, basically a list of the line-by-line differences between version A and version B. Git does things differently. It thinks in snapshots. Sorry, zoned out. Um, yeah, Git does things differently. It thinks in snapshots. What is a snapshot? Think of a snapshot as a miniature file system. When you make a commit, Git doesn't just record what you changed. Git doesn't just record that you changed line 10 of index.html. Instead, it takes a picture of your entire project. Looks what? Instead, it takes a picture of what your entire project looks like. Okay, sorry. Um, instead, it takes a picture of what your entire project looks like. And at that exact moment, give me a second. There's too much silence going on here. Just a second. I'm doing some stuff. Okay, now where was I? Yeah, instead it takes a picture of what your entire project looks like at that exact moment. Technically, a snapshot is a collection of objects, specifically blobs, for file data and trees for directory structures stored in Git's internal database. How Git efficiently stores data. To keep your project from ballooning in size, Git uses a clever trick called content addressable storage. If a file changes, Git creates a brand new blob object containing the entire new version of that file. Okay. If a file stays the same, Git doesn't copy the file again. Instead, it just creates a link or a pointer to the existing version it already has stored from a previous commit. Okay. Okay. The anatomy of a commit. When you hit git commit, Git creates a commit object that contains three main things. A pointer to the snapshot. This is a reference to the tree object that lists every file and folder in your project at that moment. Then metadata, which is the author, the date, and your commit message, and then the parent pointer, a reference to the commits that came immediately before it. This is what creates the chain or history of your project. Okay, visualizing the structure. Imagine your project has three files. You know what? Let's visualize it here. Um, where did I create the thing? Here. Okay. So we're gonna create a new file. I created this repo just to play around with. This is the repo. We're going to be making whatever changes we are making to this. Okay, let's say sum o2, and we'll save it so the file is there. So it's saying we have three files, okay, A, B, and C. So we're going to follow along with this. Where did that come from? Copyright. What? Oh, snippet tippet copyright. That's interesting. Oh yeah, dude, I should look into snippets. I feel like that might be useful for me in certain situations. Yeah, I feel like that might be useful for me in some situations. Okay. Um, right. Version 1. In version 1, you commit all three. Git stores three blobs. Okay. How do we visualize this? Um, I guess let's visualize it like this. So we have 0, 0. I don't know if this is a good visualization. 0. Or Actually, no. You know what we can do? We'll do A1, A2, A, sorry, B1, and C1. So used to writing C sharp that I immediately wrote C sharp. Anyways, um, so that's version 1, okay? You commit all 3 and Git stores 3 blobs. Great. Version 2, you change file A, so Git creates a new blob for A2, okay? We're going to do A2. It then creates a new snapshot that points to A2, but still points to the original B and C. Okay, that's interesting. So I guess that's a good way to... Is that a good way? I guess we better write it like this. B, yeah. Though, I mean, we want to say that we're not storing the file, right? We want to say that it's a pointer. Oh, to represent a pointer, we can do an asterisk. Yeah, that's better. So this is our pointer. Okay, then, um, right, so in version 2, you change file A, Git creates a new blob for A2. It then creates a new snapshot that points to A2, but still points to the original B and C. Okay, then in version 3, you change file C. So Git creates a blob for C2, and the new snapshot points to A2, C2, and B. So let's visualize that as well. Okay, new snapshot, C2, but then there's no change here. So we just continue. Oh, actually, then I don't need to do this, right? I can just do it like this. So that's a pointer. What happens to A2? A2 is also a pointer. Okay, so we do asterisk. Right. Okay. Right. Why this matters? Because Git stores snapshots rather than just changes. It is incredibly fast at switching between branches or versions. It doesn't have to calculate what file. It doesn't have to calculate what a file looks like by adding up 100 different diffs. It just looks at the snapshot for that commit and pulls the files it needs. Does the distinction okay, yeah, that's just a question to continue the convo. Um, okay, help me understand how all the blobs of different versions are being stored. Are they all in just one um, directory, or wait, one directory perhaps with subdirectories, or is there some other way that they are stored? Because I'm assuming that they'll get stored. Maybe this is one way, because I've seen like a long string of characters. Maybe I can show it here. Hold on. Let's go into Yahtzee and show this. And I did make one commit. I don't know if this is the first commit. Head is pointing to that. I think that is the first commit. I'm not sure. Yeah, okay. Let's say this. I'm assuming that this is meant to be like the file hash or the hash of the blob, and then this probably gets stored somewhere. So then that database tells us where to look, um, tells us which file to look for to get the blob. Give me a second. Let me refresh this feed. Okay. Okay. All right. Or is there some other way that they're stored? And how does Git know um, which blob to look for and where to look for it? Also, you mentioned that Git would create a snapshot containing the new blob, but pointers to old blobs for the unchanged files. I'm having trouble visualizing what that looks like. Now, okay, I'm doing all of this digging into, how things are working. If I'm being honest, this is not really going to benefit my learning of Git all that much. Well, it's not really going to benefit my learning and usage or my practical knowledge of Git because it's not really teaching me the practical stuff. We will be getting into the practical stuff. We have to, continue reading whatever is on this page, but I do also have those doubts, so I wanted to clear them up. Okay. Git keeps everything organized in a hidden directory called .git/objects. Okay, let's look for that. We have .git and we have objects. All right. Oh, wait, 5.3 and 8D and E1. I'm seeing three of these. Let's see 8D. Yeah, this is our commit. I'm not sure what this is. Maybe this is a hash of the blob. Um, and so maybe this is what gets stored as, um, this is what gets stored in whatever database Git is maintaining. What are these other two though? We have something called 5.3 and E1. I know that 8D is from our commit here. So if I look at there, there's supposed to be a way to see like a longer version of these commits. I don't remember what the method is. Yeah, I can't remember what the method is. Um okay. Anyways, carrying on. It's essentially a key value store and the key to everything is a SHA-1 hash. How Git identifies files, the hash. Git doesn't look at a file name like readme.txt to find data. Instead, it looks at the content. When you stage a file, Git runs the content through an algorithm to produce a 40-character hexadecimal string. Example, so-and-so, so-and-so, so-and-so. If two files have the exact same content, they get the exact same hash. If you change even one comma, the hash changes immediately. This hash is the address of the blob. Okay, okay. To keep the git/objects folder from becoming a mess of thousands of files, Git takes the first two characters of the hash and creates a subdirectory. Okay, that is our directory. Hold on here. That's our 8D directory. Okay, all right. Um, to create a subdirectory and uses the remaining 38 characters as, oh, it uses the remaining 38 characters as the file name. So to confirm that, we can check here. Yeah, it says 8df2aca. So our directory's name is 8d and the file's name is f2aca and then whatever else. So this is the hash of one blob. What if there are multiple files involved? Okay, if there are multiple files involved, would the hash for each blob start with like the first two characters of the commit? I wanna test this out. So let's say, so now we have two files, right? We have two files. We are gonna save this. I'm gonna make a change here. I'm gonna say this is another sentence and save it, and then come here. And now we have this. Okay, we're going to stage the change. We're going to commit it. Um, second commit. Okay, committed. Great. What is the thing? It is EB. Was EB there already? I don't remember. No. Oh, this is interesting. So now we have more folders, more directories here. I think we had E1 before and 5.3. Um, Now we have a couple extra things here. So I'm guessing it made a new blob for sum O1 because there's a change to sum O1. It made a new blob for sum O2 because there's a change to sum O2. But um, how is it working? So okay, hold up. Let's go back to this. So it's EB 0BBA6. Okay. EB, where is EB? Here. 0BBA6. All right. Does anything else have 0BBA6? No. So then what are these other things? Give me a second. I just realized that I forgot to open up my chat on my phone. So I'm just going to do that real quick. Give me a second. Oh shit, I forgot I'm supposed to put my phone on charge as well, so let me do that. By the way, are we good on frames? Oh shit, no. At some point we started to drop frames and I didn't even realize it. And now we are back. Okay, all right. Let's refresh this feed. Dude, you know what? Whenever I make my whenever I finally get around to making the OBS remote control terminal application that I've been planning on making, I should also introduce controls for stopping and restarting the RTMP feed, because this way I won't have to come into OBS and constantly be keeping an eye on things. Something that I should do is make sure that I always have a view of what my stream looks like. Because one of the problems that I run into is that I usually don't have a view of it. Though, I mean, now, now I can actually do that. Now I can actually have a view of my stream. I don't need to open up my stream on my phone anymore. I can still do it. Um, but like now I can open it up on my I can open it up on my other machine. Um, and that way I'm because previously the reason I wouldn't be able to use that same machine on which I'm capturing the RTMP feed, I wouldn't be able to use that same machine to view my stream is because anytime I would move focus away from the Kitty terminal, OBS would stop capturing it. Now though, with Westterm, fortunately that doesn't seem to be an issue. I don't know what I did different in this case. I have no idea what I did different. I don't know if maybe I'm using a different capture method, or if it's a difference between the Kitty terminal and Westterm. I have no idea. But I can comfortably, move away from that window, and I can be confident that OBS is going to keep capturing that window. Now, keeping that in mind, I feel like actually is does the matrix rain still work? I believe it does. I believe it does. Yeah, I'm still seeing it. I am definitely still seeing it. Let's stop the feed, start it back up. Oh man, there's some latency today. Holy shit. Yeah, dude. I guess I can I haven't done this in a long time, but now I can like the expand the view in my stream manager. Previously, I'd removed that. I'd made it so I'm not looking at the stream preview in my stream manager. Now though, I feel like I can have it open. You know what? I didn't realize that. This is something that I didn't realize because for the past, I don't know, a good year or so that I've been doing for the past year that I've been doing what do you call it? Terminal based streams. I for the longest time it was I was using like a fixed workflow using the Kitty terminal and using OBS, and there's a specific way that things worked. Um, but like now, dude, I mean things have changed. Now things have improved. But yeah, okay, cool. That's great. So now I'm able to look at my stream on the same system that I'm well, anyways, yeah, it's my entire setup. It's hard to explain when I say that now I'm able to watch it on my system, but then I've got like four systems in front of me right now. From one of them, I'm streaming to Twitch. From the other one, I'm streaming to the system that I'm streaming to Twitch from. So that's where the RTMP feed is coming from. And then from another one, I'm SSH'd into this machine from which I'm streaming the RTMP feed. I'm SSH'd into this machine from the other machine to be able to control it using a Westterm instance. Um, yeah, yeah. Anyways, it's good to be able to look at my stream manager page again because for words, holy shit. Because for the longest time, I had been looking at each time I would say that I have to open up my chat on my phone. And it was because, the thing wasn't being captured. And I would also run into these issues where I would have like the browser, blocking something because I made the window big enough so everybody could see better. Um, but then like I would forget to change that, and because of that, I would not be able to. I wouldn't realize that, oh, this is blocking stuff. And actually, I just figured out another use case that I might have, but this is nothing to do with the stream. Give me a second. Sorry, I'm just looking into something right now. Um, Hold on. Oh, wait, this is interesting. This is showing that. Oh, this is showing something else. Okay, never mind. Hold on just a second. I'm just doing something here, and for some reason, this is being a little bit slow. Okay, let's close this and reopen it. By the way, I'm pretty excited about the fact that I've started now posting content more regularly, especially with, this content pipeline workflow that I have now. I've started I've started posting content more regularly for the past, like, I don't know, 4 or 5 days. I've been posting content regularly. Every now and then I'll extract clips from, whatever past stream I'm doing. Um I'm currently on stream on the 30th of March. So I have to do 30th and 31st of March. And with that, we'll be done with the entirety of March. And then I'm going to be going through all of the clips from, sorry, all of the streams from April. Well, using my tool, I'm going to be going through all the clips from the entirety of April. And I'll have a bunch of stuff to post. Okay, all right. So, what was I saying? Actually, there's, sorry, there's one more thing that I need to do. There's one more thing that I need to. Okay, whatever. We're gonna continue with this thing. So, we are learning about Git stuff. Right. Okay, visualizing the snapshot. You mentioned having trouble visualizing how Git mixes new blobs with old pointers. The quote-unquote snapshot is actually a tree object. Think of a tree object like a simple text file that acts as a directory listing its maps, file names. What? That acts as a directory listing. It maps file names to their hashes. All right, so main.py, hash pointer, status new blob, so and so. Okay, that's in commit 1. And then in commit 2, you only change so and so. Git creates a brand new blob for the updated so and so, and then it then creates a new tree object for this commit. Okay, is there a way for me to view the commit, or is that in like binary? I think we'll look into that as well. All right, how Git knows where to look. When you want to check out, quote unquote, check out a specific commit, or move back in time, Git performs a simple lookup. it reads the commit object to find the top level tree hash. It goes to object. It goes to the object fold. It goes to the objects folder and opens that tree. It sees a list of file names and their hashes. It grabs the content from the corresponding blob files in the objects folder and places them into your actual project folder. This is the working directory. Okay, all right. Okay, so I just tried something. Wait, you know what? Let's do something here. Okay, I am gonna delete this entire database. I'm gonna delete this as well. I'm gonna delete this as well. What happened to? Did it crash? Yeah, could not find repo. Okay, that makes sense. That makes sense. Siri did not crash, but I'm guessing now it crashed. Okay. Yep. Um, oh, I think I need to reset it. Yeah, there you go. It crashed so bad that it messed up the terminal state, so I had to reset the terminal. I guess I should report that if you crash Siri in this way, it leaves the terminal in like a weird state. Um, is this okay? Yeah, this is okay. Right. So we're going to create a new repo here. What happens to these things? Okay. All right. That is done. At this point, I want to initialize a repo here. So we're going to do git init. That creates our repo. In our repo, we have nothing so far. Info and pack are empty. Okay. All right. So I'm going to write this down. Um, Actually, this can be our first commit as well. We'll write it within this thing itself. Where is it? Okay, git observe, git observer. Yeah, let's call it git observer. Um, so created new, not created, initted, so initialized, new repo. And what's the directory structure? Okay. So objects contains info and pack. All right. Okay. Uh, dot git slash objects slash info dot git slash objects slash pack. Okay. Um, oh, let me mention here, empty, empty. All right. So we're going to save this. And now what we're going to do is, let's also create some O1. And here we're going to add our first thing. This is, oh God, there's going to be two files here. That's going to be a problem. That is going to be a problem. If we are trying to track how this works, I need to move this file out. Let's close this here. Let's open. Actually, we'll move it out, and then I'll open it from within here itself. So I will create a new thing here. Let's go back here, come here, cut this, don't search, cut this, and let's go into empty directory and paste it here. Speaking of pasting, I just remembered something. Okay. All right. Okay. Where was I? Actually, let's refresh this feed real quick. Okay, our thing is here. Now let's go back here and come here and open this up. And we're going to go back one step, go into empty directory and open up Git Observer. There. All right. So now we're good. This is a sentence. We're going to save this, come here, open up Git UI, make our commit. This is first commit. Also, wait, real quick. Let's go into Yahtzee. Oh, see, now we already have something here. We haven't made the commit yet. We've staged it. We've staged it. Let's back up and undo the commit. Let's unstage the file. This still remains there. That is very interesting. This remains. So it seems like it's making a blob. How is it keeping track of? Oh, I think it's Git UI that's calling whatever Git related functionality needs to be called. And that's when it's creating this. I need to recreate this again. We're gonna turn off Git UI. Um, and I'm gonna delete this. And I guess, yeah, I don't need to delete the entire thing, right? I can just do git init. Okay, right. So we have this. So far, this is what we have. Okay. To test this out, let's go into, dude, I love Zoxide. It is so convenient. Holy shit. Okay, we're gonna do git status. Nothing. Okay. Nothing has been done so far. Um, if I do git add sum 01, now it added this. All right. So when I staged it using Git UI, that is when it created the blob. Right. So I'm gonna explain this to, you know what? Wait. Um, I need to write down this observation. Where's Neovan? Here. Uh, Initted new repo. Okay. Created sum 01 and added text. Um, then created sum 01 and added text. Then staged sum 01. Dot git slash objects slash where exactly is it? Um, it's in objects. Oh, not in info or pack. It's under E1 directly. Okay. All right. So E1 created um, dot git dot objects dot e1 slash, what is the thing? Let's say 60289. 60289 Z2 2289. 2289 dot 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 created. Let me also mention not committed yet. Right, so we go next, and then what are we doing next? So we make the commit. Let's make the commit. Oh, okay. Hey, so for the sake of understanding, I'm, dude, I feel like I'm just wasting my time with, I'm not really wasting my time. It's like, I'm trying to get an understanding of this, and that's why I'm doing this. But in terms of making progress with learning practical Git workflows, this is not really helping. This is just helping my understanding of how Git works. I need to find the right spot to, stop here, um, and not go too deep into it. But like, I do want to, move forward with this observation and understand what's going on. Okay, hey, so for the sake of understanding, I'm creating a repo from scratch, and I'm noting down observations. No, creating a repo from scratch, and I'm noting down observations that I make upon actions that I take. That rhymes. Um, I'm gonna tell you the action and observation, and you explain it to me. We're gonna go step by step, uh, starting with the first um, action slash observation 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 pair. Ready? Okay, I'm absolutely ready. This is actually the best way to learn Git, but by looking under the hood at the Git directory while you work. It strips away the magic and shows you that Git is ready. Git, oh my God. It strips away the magic and shows you that Git is really just a clever filing system. Go ahead and hit me with your first action and what you observed. I'll help you break down exactly what Git did behind the scenes. Okay, so we are gonna, I don't think if I yank it from here, it's gonna work. I think I need to copy it in this way. Okay, so we yank it like this. Okay, action. Um, okay, observation. So and so. Action. Initted new repo. Oh, actually, I should do it like this. I should actually do it like this. So we're gonna do created and then created. Yeah, I'm gonna change this a little bit. So action. Um, hold on. How do I want to do this? Okay, we're gonna do action O1. Okay. Oh yeah, we can do it like this. Action observation pairs. Um, back up. All right. Observation O1. And then here we can do action O2. And then we have the observations for this. Okay. Observation O2. Give me a second. Created. Created. Okay, maybe I should rename the stream to Exploring How Git Works. I don't know if the VOD stores the current title or the title that I started the stream with. Let's do it in this way. Exploring how Git works. Okay, great start. This is the blank canvas phase. When you run Git init, Git sets up the skeleton of its database. Here's what is happening with those two specific directories. Git objects info. This directory is used for internal housekeeping. Specifically, it can hold a file called attributes for defining how Git handles certain file types, or exclude, um, which acts like a local git ignore that doesn't get shared with others. Since you haven't configured any special rules yet, it's empty. Then we have pack, so git objects pack. This is where Git's efficiency lives. Right now, as you start adding files, Git will store them as quote unquote loose objects. So individual files in subdirectories like objects/5d. Over time, having thousands of tiny individual files is inefficient for disk space and network transfers. Eventually, Git will quote unquote compress those loose objects into a single pack file to save space. That .pack directory is the designated parking spot for those compressed bundles. I don't think I noticed that it said dot. Oh, no, it doesn't say dot. Okay, anyways. Okay, the big picture. Notice that the main objects directory is mostly empty right now. Git hasn't actually recorded anything because you haven't told it to track any content yet. In Git's eyes, an empty repository doesn't have any quote unquote state to remember. It's just an empty warehouse waiting for the first crate to arrive. All right, what's your next step? Are you creating a file or staging something? Okay. Action 2, created some O1 and added text to it. Then staged some O1, not committed yet. Observation, E so-and-so created. Actually, if I yank this, is this gonna... No, it doesn't. We need something else here. We need... Okay, let's just do it in this way. Okay, we yank this, paste it. That works. Great. Awesome. It maintains the formatting as well. Okay, action O2 created some O1 and added text to it, then stage so and so. Okay, this is a huge quote unquote aha moment in Git. Gemini says this a lot, the aha moment. It's like, aha, okay, I never say aha. Though I think I say something, I think I say something like in place of that, because my thing will mostly be like, oh shit, oh damn, oh okay, oh yeah. I think mine is oh. I think mine I think mine is oh. All right. Anyways, notice how you haven't committed yet. You haven't even committed yet, but Git has already created an object. Here's what just happened. The quote unquote staging magic. In most version control systems, nothing happens until you commit. In Git, the moment you run git add, it says, I need to protect this data immediately. Hashing. Git looks at the text you wrote inside some O1. Um, it calculated the SHA-1 hash of that content. In your case, that hash starts with EB so and so so and so. We should try calculating the hash of these files to see if we get like a similar thing. I mean, that's only going to work to a certain extent. Um, yeah, that's only going to work to a certain extent. What's an easier, what's the easiest way to do this? We can do with open. We can do with open file.read, I believe. I would need to have, I mean, I have a Python interpreter open. I can just do with open so and so, and then it'll read the entire thing and give me the hash. Okay. Anyways, let's continue with our observation and, well, our actions as well. So instead of a new file, we're gonna do this. So this is another sentence. Oh, wait. Oh, let's not save this. Let's not save this. Let's commit. We need to add that as the next action. So we'll stage the change, make our first commit, and that's done. Okay, what does Yahtzee show us now? Okay, we did the commit. We did the commit. So I need to log these. Um, so we're gonna come here, action 03, modified, no, not modified, committed, staged file. Um, yeah, that's it. And then we have our observation, observation 03, dot git slash objects slash what all is created here. Hold on. I need to have Yahtzee open here as well. Um, it'll be easier for me to like jump around. Uh, yeah. All right. So objects E4 and then 3A, E9A. Okay, E4 created, um, and then dot git slash objects slash E4 slash 3AE9A. 3AE9A. Was there a D? There was. Created. Right, and then we do, there has to be an easier way to do this. Hold on. Yes, there is actually. I could, well, in terms of getting, I mean, I could get the directory path. Give me a second. I'm not sure what this is going to show. So, I'm going to stop this for a second. Okay. Right. So dot git so and so so and so created, and then this, delete that, slash what was it? 4105D9. 4105D9 created. And was there anything else created? Oh no, I think we're good. Yeah, we're good. This is a bit tedious, having to note down all of this. Not a bit, this is very tedious, but we kind of have to do this. So I'm going to save this now. Um, oh wait, I just realized that I'm not done reading the entirety of Gemini's Gemini's response there. Okay, the staging magic. In most version control systems, okay, that's done. Hashing. Git looked at the text you wrote inside sum01. It calculated the SHA-1 hash of that content. In your case, that hash starts with e so and so so and so blob creation. Git took your text, compressed it using zlib, and saved it as a blob or binary large object. The address, it used the first two characters, which is E1, as the folder name, and the rest as the file name. Key observation, the file name is missing. If you want to peek inside the file right now, you would see, if you were to peek inside that file right now, you would see your compressed text, but you would not see the name sum01 anywhere. That's interesting. This is compressed, yet I would able to I would be able to see the the text. Let's try creating a hex dump of this. Where here, hex dump c dot git, not dot git slash objects slash e1 so and so. That's the text we have so far. This is compressed text. This is compressed data. So I'm not seeing the text that I wrote there. However, Git probably has this stored as this, file version. All right. Okay. Give me a second. Let me refresh this feed. Done. Okay. Great. Now, what was I doing? Yeah. At this stage, Git only cares about the content. It has stored the quote unquote what. Well, not quote unquote, but it has stored the what, but it hasn't stored the where, that is the file name, or the when, that's the commit, yet. All right. Where's the file name sum01 stored? Since it's not in the object folder yet, Git keeps track of the connection between the file name sum01 and the hash in a special file called the index, located at git in. Oh, damn. Okay, I should have looked at this before I made the commit. Oh, seems like we can't really see the file anyways. It says git index version 2 1 entries. There would have been a version 1, but actually version 1 was the non-committed thing, right? Version 2 then becomes the entry that we made, the one entry. Also, I didn't realize that Git UI creates its own thing here as well. That's interesting. Good to see though, because Yeah, this will be useful information because it's storing like all of the commit messages for me. Okay, unnamed repo, edit this so and so. Okay. Let's try to read. We cannot read this. This is binary data. Okay. All right. Give me a second here. Okay. All right. Um, okay. All right. Let's go back to this. Ready for action O3. Oh, wait. The index is a binary voice crack. The index is a binary file. I probably should have read that before. The index is a binary file that acts as a staging area. It's basically a simple list that says, next time we commit, I want the file named sum01 to use the content found in blob so and so. Okay. Ready for action O3. I'm guessing a commit is coming up. Yep, you guessed right. So let's copy this, yank it, and drop it in here. Okay, you just witnessed the quote unquote snapshot being born. Notice how even though you only added one file, Git created two new objects. This is because a commit is a multi-layered sandwich. Since the file content, that is the blob, was already created in Action O2, Git now had to build the structure around it. Here's the breakdown of those two new objects. Okay, the tree object, that is a snapshot. One of those objects, likely 5341 so and so, is a tree. As we discussed, the blob, hold on. Did we do a hex dump of that? No, we did not do a hex dump of that. Let's try that. Let's do 53. I'm not sure what I was expecting to see. It's binary data, so I'm not really gonna. I could look at the. You know what's interesting? They both seem to start with 7801. What about the other one? This is what 843A something. Okay. This one also starts with 7, but this has a lot more information. Is this the tree maybe? And yeah, this also starts with 7801. Are we dropping frames? Oh shit, I just realized that. I think we're dropping frames. Or we were dropping frames? Give me a second here. I'm just doing a couple of things to hopefully smooth things out a little bit. I hope it helps. I'm not sure. Oh God, I don't know if it helped. I think it made it, well, okay, it helped to a certain extent. Um, yeah, things are a bit better now. Okay, anyways, carrying on. one of those objects, likely 53 so and so, is a tree. As we discussed, the blob doesn't know its own name. The tree is the missing link. If you could cat file, if you could cat file that object, you would, it would look something like this. Would it? Okay, we can try that. Let's do let's see what bat says about this. Nope. Let's try, what was the other one? Five something? Okay, that's interesting. So um for the other one, it's reading the data. For this one, it says that it's binary and it doesn't print anything. All right. Okay. Um okay, what is it saying? You'll see something like 10064. If you could cat file that object. Yeah, no, it's not saying what Gemini is saying it would say. Oh God, dude, we are dropping frames like horribly. Just a second. Are we okay now? Hopefully. I don't know. Right. I think we are better now. Yeah, I don't know, dude. It is unfortunate. We are having some frame rate issues, but hopefully you guys can still hear what I'm saying, so things should be okay. All right. It maps the file name sum01 to that content hash you saw in action O2. This object represents the state of your, oh, what did I just do? This object represents, ah, this object represents the state of your directory at the moment of the commit. All right. Okay. The commit object. The other object, likely E4 so and so, is the commit itself. This is the envelope that um, that wraps everything together. It contains the hash of the tree object, so it knows what the project looked like. It contains your name and email, the timestamp, the commit messages you just wrote. Okay, and that's it. Okay, all right. Why this is cool? If you were to edit sum01 and commit again, you would see a new blob for the new text, a new tree pointing to the new blob, and a new commit pointing to the new tree and pointing back to the first commit as its parent. I have a question regarding this. Hey, I'm learning about Git, Git's inner workings, and I'm trying to make sense out of the files in the dirs and files in .git slash objects. Specifically, I'm trying to derive, what do you call it? A tree object and commit object info from the files. But all I see is binary data. Am I meant to at all be able to see this info? Also, I noticed 7801 bytes at the beginning of each of these files. What's that for? Some sort of magic number? All right, so I'm gonna look into this later on. For now, we continue with this. Okay, why this is cool, if you were to edit sum01, then and commit again, you would see a new blob for the new text, a new tree pointing to the new blob, and a new commit pointing to the tree and pointing back to the first commit as its parent. All right, observations so far. Staging equals created the blob, and committing created the tree and the commit. All right, you now have a complete permanent record of your project's first breath. What's the next move? Are we changing the file or adding a second one to see how the pointers behave? For now, I think I want to change the file. I've made some changes here. Yeah, so we're going to do, this is another sentence. Okay. Um, Now, the first thing we're going to do is stage. First thing we're going to do is stage. Um, nope, don't do that yet. We need to come back here. So we just added 7, 9. All right, so we're going to note down this observation. So action 04, modified sum 01. Modified sum 01 and staged. Observation 04. Dot get slash, oh wait, I can probably copy this thing. Though if I copy it from here, I don't know if it'll pay. Well, yeah, that's fine. That's fine. Let's copy the path and paste it here. Okay. We can delete the rest after this point. Oh, actually, um, created, and then so and so has also been created. Right, this is our next observation, right? So do this, come here, yank. All right. Wait, did I get the... No, no, okay, we're fine. Exactly as expected, because you changed the content of the file, Git has to create a brand new blob. What happened? When you ran git add, Git performed the following. It read the modified sum01 file. It saw the new text, hashed it. The new content produced the SHA-1 hash starting with so and so, and then it stored the new blob. So it created the directory 79 and the file 9e so and so. Key insight: no deltas yet. All right. Notice that Git didn't look for your old file and say, okay, the user added 2 new lines. Let me just store those two lines. Instead, it took the entire new version of sum01 and saved it as a complete standalone object. Okay. The current state of your warehouse, quote unquote warehouse. Right now, oh God, dude, we are dropping frames badly. Hold on. Does it look this bad on my phone as well? Because rarely have this issue on my phone. Right now, during today's stream, we seem to be like just dying in terms of frames. Give me a second. Oh, we are dropping frames again. Yeah, let me pause this. Oh, okay, hold on. We were dropping frames. We are smooth now. Not sure what's going on. I actually didn't restart my router either today, like before today's stream. I should have done that, but I didn't. All right. Okay. Oh, I have to turn off audio only. All right. Okay, let's open this up again. Yeah, dude. I mean, we seem to be okay so far. I don't know, dude. I don't know. Let me switch back to audio only on my phone. Hopefully it doesn't consume too much of my bandwidth. But anyways, okay, the current state of your warehouse. Okay, there we go again. Now it's misbehaving again. Okay, let me see if it's also misbehaving on my phone. Wait, I have no idea, dude. I I don't know. Whatever. So, uh okay, the current state of your warehouse, quote unquote warehouse. Right now, in your .git slash objects folder, you have a blob. That's the original version of Sum01. You have a tree. That's the map of your first commit. So it's listing out all of these um, like the what do you call it, the beginning characters of the hash as well, and it's saying, okay, now you have this, now you have that, and so and so. And then you have the commit, which is your first commit object, and then you have another blob, which is a new version of Sum01. Crucially, you have two different versions of the same file existing simultaneously as blobs. The quote unquote index, which is the staging area, is currently pointing to the new one, but your previous commit is still safely pointing to the old one. Now, real quick, speaking of the index, if we come here, it still says version 2, 1 entry. Right. Okay, if you commit now, you're going to see another tree and another commit object appear, ready to see how Git links the new tree to this new blob while remaining in the past. Yeah, okay. Let's do that. Let's come here and here, commit. This is our second commit. Done. Um, so what got created here? Oh God, I'm gonna have trouble keeping track of all of this. Did we have EE before? Let me look at what Gemini listed out. So we had E1, 5.3, E4, and 7.9. So E3, oh God. No, we had E1. Yeah, E1. Didn't we have 8.3 at the beginning? No, we didn't. We had E4. Okay, so we have E1, 5.3, E4. E1, 5.3, E4, and then 7.9. That leaves us with what? E3 and EE, I guess. Yeah, yeah. So in order to create the observation for this, we can just paste this and make edits to it. O5 committed staged file, observation. It created, what did it create? It created E3. So it created E3 and E3 5414 E0. E3 5414 E0. And the next one was EE. That is EE, and then more E's. Hold on. EAED2D. Okay, all right. So I'll save this and let's copy this or select it and then yank it and paste. You've just completed the quote-unquote linking phase. You now have a second snapshot, and Git has officially established a history. Just like in Action 03, you see two new objects. One is the tree, and one is a commit. The new snapshot, the tree, one of those objects, likely so-and-so, is the new tree. If you could peek inside, it looks very similar to your first tree, but with one critical update. Instead of pointing to the old blob, it now points to the new blob you created in Action 04. The new commit, the parent link. The second object is your new commit. This is where the chain of version control is actually formed. This commit object contains a pointer to the new tree, your metadata, so name, date, message, and the parent pointer. It contains the hash to your first commit, the big picture, how they're all connected. If you were to look at your Git objects folder now, you have a complete ecosystem. Here is how the pointers flow from the top to down. Commit 2 points to tree 2 and commit 1. Tree 2 points to blob 2, the new version of Sum01. Commit 1. Oh, commit 2. So that's now our second commit. Okay. Commit 2 points to tree 2 and commit 1. So commit 1 is the parent commit. Do they call it the parent commit or parent pointer? Parent pointer. Okay. Tree 2 points to blob 2. That's the new version of Sum01. And commit 1 points to tree 1. Tree 1 points to blob 1. Okay. All right. You know what? Um, I am unfortunately out of time for today. I think I'm going to leave this as is, and tomorrow we're going to continue doing Git again. Um, but this time I'm going to actually, go through like the proper practical Git workflow. Or maybe I can complete this off stream and satisfy my curiosity off stream. This entire observation thing that I'm doing, I can maybe do this off stream and satisfy my curiosity off stream, and then tomorrow we can do actual Git stuff. But we made some progress today. I got to learn stuff. Hopefully, we got to learn stuff. Anyone who watches this VOD later or watches a clip or whatever got to learn stuff. Um, I'm 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 happy about that. And even yesterday, by the way, I made progress with the Forest Mems book. Actually, not with the Forest Mems book, but I continued doing the analog electronics research. I'm continuing reading up through Gemini, trying to understand the whole thing with atoms, what are atoms made of, how electrons, protons, and neutrons work, what are their different properties, and um, what makes some atoms loose, what makes some of them, very tightly packed, and all of that kind of stuff. It's pretty informative. But yeah, okay, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.